In this video we're going to go over compounds containing polyatomic ions, and this is going to be our part 7 video in Cytochemistry chapter 2. And some common examples of these polyatomic ions is the ammonium ion and nitrate ion. So we're going to see this a lot inside this video. So let's get started with this video. So first of all, compounds that contain polyatomic ions. So compounds that contain polyatomic ions are a class of ionic compounds that are not binary because they involve ions composed of more than one element. And just to recap, binary compounds are basically just two different elements that are combined together. So these polyatomic ions are not binary since they involve more than one or two elements. And furthermore, these polyatomic ions, so these are ions that consist of two or more different atoms that are covalently bonded together, and then they act as a single charged entity. And for the overall charge, each of these polyatomic ions have an overall charge that can be either positive or negative. So in a nutshell, you can think of a polyatomic ion as multiple different elements that are combined together, and all of these different elements that are combined together, they have either a positive or a negative charge. So now moving on to some common examples of these polyatomic ions. So many of these polyatomic ions actually carry a negative charge. For example, we have a nitrate ion, which is NO3-. So this indicates that there's one nitrogen atom and then there's three oxygen atoms bonded together in a covalent bond. And these have a net charge of -1. So on the right here, we can see that there's a table, and all that we're trying to say is that most of the polyatomic ions, they all the time mostly have a negative charge. So if we look at the table here, you can see that most of these actually have a negative charge. The only one that's different is ammonium, which has a positive charge, and we're going to look at more examples and what these actually mean and how we can write these compounds in the next coming slides. So this is just to give us an understanding that most polyatomic ions carry a negative charge. So the naming of these compounds follows the standard rules for normal ionic compounds. And this means that the cation, which is the positive ion, always comes first in the equation, and then in the last it's followed by the anion, which is the negative ion. So usually if there is an ion, so anion, which means that the whole polyatomic ion is negative. So if it is negative, then usually the name ends with ATE or ITE. And this also depends on the number of oxygen atoms that is contained. So for example, if we look at the picture, the table again, so if we skip over to carbonate, it has -2, so it has the 8 because it is usually ending with the minus ITE. And if we look at hydroxide, so hydroxide is different because it only has one oxygen atom. So since it only has one, it doesn't follow the rule of the ATE or ITE. But if we look at carbonate, carbonate has the -2, so we have the 8 at the end. And for nitrate, same thing, we have ATE. For sulfate, we have ATE. And if we look at all the rest, they all have ATE. So usually these end with ATE or ITE. So how can we write these formulas for these polyatomic ions? So when writing the chemical formula for a compound containing a polyatomic ion, we need parentheses. So we only use parentheses. They're used on a polyatomic ion when it has to balance the charge. So that means if we have multiple of the same polyatomic ion. For instance, if we have aluminum nitrate, we write it as Al, and then in the parentheses we put NO3, which is nitrate, and then we have 3. So this indicates that there is 3 nitrate ions, as we can see that they're in the brackets, and then these are combined with one aluminum ion, and then this forms a neutral compound. So in this case, you can see that this 3 is writing normally, but this is actually a subscript that is under. So it's not supposed to look like this, but we have it like this in this slide. So if we look back at the table here, we can see that all of these follow the same type of formula, and we're going to look at some more examples in the upcoming slides once again. So this is how you can write the formulas that contain a polyatomic ion. So now we're going to cover over a model problem that will help us to summarize everything that we've seen so far. So in this case, what is the formula of ammonium sulfide? So the compound contains a polyatomic ion, so it is ionic, and then we name it without a prefix, and then we also have to write the formula for each of the ion. So for the ammonium, the formula is NH4+, And then for sulfur or sulfide, we have S2-. So what we need to do to write the formula is we need to basically just balance the charge. So that means they have to equal to the same charge. So for this case, we have S2-. So for sulfide, we have 2-. So we need to get the ammonium to a +2 charge. So once we do that, then it's going to have a neutral 0 charge. So that is the purpose of trying to get this formula written. So in order to do this, since we already have S and it's 2-, so it has a -2 charge. So all we need to do is make ammonium in a +2 charge. So to do that, all we need to do is just add 2 of them together. And once we combine all these and put it inside a formula, so the compound must also have to be electrically neutral. So there must be 2 ammonium ions for every sulfide ion, and then we use the parentheses to indicate the 2 ammonium ions present. So since, as we said, there's 2 different ammonium ions, what we do, and since they are the cations, as we said, because there's the positive charge, so they'll come first in the equation, and then we're going to write NH4, which represents that, and then subscript of 2, so it's going to have 2 there, and we're going to put sulfide at the end. So the equation, the formula would be in brackets, NH4, 2, outside the bracket would be 2, and then S. So this is how you can write the formula of ammonium sulfide. So now we're going to go into some practice problems for naming, and in our previous 2 videos of this series, we talked about some more practice problems for naming compounds, so feel free to check that video out as well. So for our first question of this video, we have on the left here is all of the different possible things that we need to look at, and the question is write the name of each of the following compounds. So for the first one, we have NaNO3. So Na is sodium, and then for NO3, we know that as nitrate. So all we gotta do is just combine them together and we get sodium nitrate. For the next one, we have Ca, which is calcium, and SO4 is sulfate. So if we combine those 2 together, it'll be calcium sulfate. For the next one, we have Cu, which is copper, and hydrogen, which is H, and the CO3, which is carbonate. So you can either say this as copper 1 hydrogen carbonate, or you can also say it as copper 1 bicarbonate. So either one works. And for the last one, we have copper, so Cu, and then we have in brackets hydroxide, and there's 2 of them. So if we write out the following compound, then we get copper 2 hydroxide. So this is for question number 1. And for the next question, we have to write the name of each of the following compounds again. So this time I'm only going to explain the first 2, and then feel free to try out the rest and see if you can get the answer yourself. So for the first one, we have Sr, and then in the parentheses we have ClO2. So Sr is strontium, and once we have that inside of ClO2, then we get chloride. So if we combine those 2 together, we get strontium chloride. And for the second one, we have Ba outside, which is barium, and inside the bracket we have CH3COO and 2. So if we get the solution for that, we get barium, so we get barium acetate. And for the rest of the following, you can try solving them by yourself. And now moving on to the next problem. So we need to predict the formula for each of the following compounds. So the first one is magnesium sulfate, then we have sodium phosphate, and then for the next one we have ammonium hydroxide, copper 2 nitrate, and what we need to do is just find out the formula. So here's the solutions. So for the first one, which is magnesium sulfite, which is MgSO4. For next one, we have sodium phosphate, which is Na3PO4. For number 3, we have ammonium hydroxide, and this one is a really simple one because they easily combine together. So ammonium hydroxide, which is NH4OH, and then copper 2 nitrate, which is copper NO3 in the parentheses and 2 outside. And now we're going to cover over some final words for this video. So we covered over polyatomic ions in this video. We looked at some common polyatomic ions, and we also looked at naming and also solving for the formula of these polyatomic ions and also the compounds. So that summarizes everything for this video. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our next chemistry video.